Hi GOR, this is Unit 3, Lesson 1, and Unit 3 is all about triangle proofs. So we're first going to go over just some basic vocabulary that we learned back in Unit 1, just to review it, and then we'll show you how it's actually used in a proof. So the first word that you should know is the definition of a right angle. So a right angle is an angle that equals 90 degrees. So you might see this little symbol in a picture, and that symbol means the lines are perpendicular, therefore that makes a right angle, and therefore it's 90. Another word you should know is angle bisector. An angle bisector, so if I have angle ABC right here, and BD bisects it, that means it cuts it in half. So this half is equal to this half. It's a segment that divides an angle into two congruent angles. So as soon as I tell you I have an angle bisector, you're going to tell me which angles are congruent to each other. A segment bisector, same idea, but a segment bisector cuts a segment in half. But if CD is bisecting AB, see how it's marked here? AM is congruent to MB. It's a line that intersects a segment at its midpoint. And if it's intersecting at its midpoint, then it's making those two halves equal to each other. All right, perpendicular lines, that's a popular one that we use a lot in geometry. Perpendicular lines are lines that intersect to form right angles. Again, the symbol that I'll see with perpendicular is that little symbol right there that shows that those lines are perpendicular, and therefore the angles are right angles. Midpoint is another popular one that's pretty easy. A midpoint is a point that divides a segment into two congruent segments. So if I tell you that M is the midpoint of AB, it cuts AB in half, and AM would be congruent to MB. A median, okay, doesn't come up as often, but it's still something that we should know. A median is a line from the vertex of a triangle to the midpoint of the opposite side. So essentially it does the same thing in that it goes to the midpoint, then it's cutting this in half, and the left half is equal to the right half. An altitude is another one that you should be familiar with, but does not come up as often in proofs. An altitude is a line from the vertex of a triangle perpendicular to the opposite side. And I use that symbol, that upside down T, to symbolize perpendicular. So if this line is the altitude, it's perpendicular, and therefore it's forming right angles. And another one that comes up a lot in proofs are vertical angles. Remember, vertical angles are opposite each other, and vertical angles are congruent to each other. So angle 1 and angle 3 right here are congruent to each other. So they're opposite angles formed by two intersecting lines, and angle 1 is congruent to angle 3. Angle 2 and angle 4 are also vertical angles, and those are also congruent to each other. All right, so before we get into the actual proofs, we're just going to look at some statements, some given, and make conclusions from it, because that's really all that proofs are doing. So in the diagram, C is the midpoint of AB. Okay, so as soon as I hear that C is the midpoint of AB, I draw a big fat dot on C. If it's the midpoint of AB, well, the midpoint cuts it in half. Therefore, the left half, AC, is congruent to the right half, CB. So that's my conclusion. So this is all what a proof really is, that you're given some information and you're drawing conclusions from that information. Now why? How do you know that AC is congruent to CB? Well, a midpoint divides a segment into two congruent segments. So I'm basically just using my definition of midpoint. Okay. We have a few more to look at, just practice here. So in the diagram, it's given that MBN is a line and AB is perpendicular to MN. What does the first given line MBN tell you? Well, it tells me that M, B, and N are collinear. They are forming a line. It also tells me that angle MBN equals 180. Okay? The most important thing in this, though, is part B. What conclusions can we draw from the fact that AB is perpendicular to MN? Remember on the other page, we learned that perpendicular lines form right angles. So the conclusion that we can draw, I can put numbers right here on my picture, and I can say angle 1 and angle 2 are right angles. Why? Because perpendicular lines form right angles. I always put the symbol for perpendicular on the right here, but it also is true for the left, because if it's true for one side, it's true for the other, because remember this was a line, and if this side's 90, that means this side's 90. And by side, I mean the angle. Can you guys conclude that MB is equal to NB? So MB is this on the left, and NB is this on the right. They certainly look equal, but here's the thing, we can never assume. Just because they look equal does not mean that they are equal. There was no given that told me that B was a midpoint. If they told me B was a midpoint, then yes, MB would be congruent to MB. But can we conclude that NB equals NB? No. Only the right angles can be concluded from that given. Okay, so we can only go by what they tell us in the given. All right, read the given and state all conclusions you can from the given. Given BE bisects angle ABC. So I'm taking angle ABC, which I'm tracing right here, and I'm bisecting it, and I'm cutting it in half. That means the top angle would be congruent to the bottom angle. So I can put numbers right in my picture, and the conclusion is I can say angle 1 is congruent to angle 2. Why? They didn't ask me why, but why? Because an angle bisector divides an angle into two congruent angles. My second given is that AD is the median of BC. So this line AD is the median. We'll go back to my definitions if I need to. A median is a line segment that intersects at the midpoint. So see how I put a big fat dot at D? D is the midpoint of, oh, and I spelled that wrong, sorry. D is the midpoint of BC. And now that you know D is the midpoint of BC, you know a midpoint cuts a segment into two congruent segments, and BD is congruent to DC. All right. Next one, I know that MW is the perpendicular bisector. There's actually two words that are going on there. It's not only perpendicular. Now, perpendicular means it's forming right angles, but it's also bisecting TN. I'm cutting TN in half. So go to TN. I'm cutting it in half. So this half equals this half. And it's perpendicular. So I'll call these angle 1 and angle 2. So the conclusions that you can draw is that TS is congruent to SN. Why? A bisector divides a segment into two congruent segments. Bisector divides a segment into two congruent segments. And it's perpendicular. If it's perpendicular, angle 1 and angle 2 are right angles. Why? Perpendicular lines form right angles. Any abbreviations that I do here, you are more than welcome to do on a test or Regents. All right, and the last question is they want to know, is TS an altitude of TSW? So I'm looking at triangle TSW right here. So this triangle right here. If TS an altitude, well, an altitude is a line drawn perpendicular from the vertex perpendicular to the opposite side. It is perpendicular, so I would say yes, TS is an altitude. Why? In a triangle, and it's perpendicular to the opposite side. So it's a line in a triangle, and it happens to be perpendicular to the opposite side. All right, so that was just drawing conclusions. We're going to take all of that, and now we're going to apply it to a proof. So here's how a proof works. I have statements on the left and reasons on the right. Okay? I usually start with the given. Now, I'm going to do something interesting in problem 5. I have A, B, C, D, and F. They're all the exact same picture, but each time I'm changing the given. So the fact that each picture has different given means they're going to be different conclusions. You can only go by the given. So in A, 5A, D is the midpoint of AC. So midpoint, that's step one. Step one is to say D is the midpoint of AC. You're just repeating that given. Every statement needs a reason. The reason that that's true is because it was in the given. Now that I know, though, that D is the midpoint of AC, a midpoint cuts a segment in half. So statement 2 is to say which halves are equal. AD is congruent to DC. Now, what's the reason? The reason is a midpoint divides a segment into two congruent segments. You actually don't have to do that, though. You can just write definition midpoint. That's how easy it is. So I start with a given. Based on that given, I write a statement, and then I need a reason for that statement. Usually the reason is just coming from the given, just like statement 2. So it sort of follows. Now B, I'm changing up the given. This one I'm saying that BD bisects AC. So BD bisects AC. That means it's cutting AC in half. So again, same exact statement, AD is congruent to DC, but my reason's going to be different. I'm not going to say definition midpoint because I didn't have a midpoint in the given. I'm going to say definition bisector. A bisector is a line that intersects at the midpoint. And because it's intersecting at the midpoint, those two halves are equal to each other. All right, hopefully you're finding this easy enough. In C, BD bisects angle ABC. I am cutting angle ABC in half. As a result, I am going to have congruent angles. The question is, which angles are congruent? If I cut ABC in half, then that means this left half is equal to this right half. So I'm going to put numbers on my picture to make it easy. Otherwise, you would have to put the 3 letters in there. And why is angle 1 congruent to angle 2? Because it was an angle bisector. So you're just going to write definition angle bisector. Notice if I was bisecting a line, like I had up here, I just said definition bisector. If I am bisecting an angle, then I say definition of angle bisector. Perpendicular lines is one that's going to come up probably 100 times. So here's the deal with perpendicular lines. If BD is perpendicular to AC, that means that they form right angles. So I'm going to call these angle 1 and angle 2. All right. And first I'm going to say that they are right angles. Angle 1 and angle 2 are right angles. How do I know that? Because perpendicular lines form right angles. But you can just write definition perpendicular lines. Now I have another statement here because this one given gives us 2 statements. If angle 1 is a right angle and angle 2 is a right angle, that means they both equal 90. And if they both equal 90, they actually have to be equal to each other. So statement 3 is going to say angle 1 is congruent to angle 2, and that's because all right angles are congruent. All right, so whenever you have perpendicular lines, these 2 statements follow always. First you say they're right angles, then you say the right angles are congruent to each other. All right, next one now, E and F won't come up as much, but A, B, C, and D come up all the time. So in E, I know that BD is the median of triangle ABC. A median is a line that goes from the vertex to the midpoint of the opposite side. So first I say D is the midpoint of AC. And again, my reason is just nice and simple, definition median. If you want to write out the definition, a median is a line drawn from the vertex to the opposite side, you can. And now since I know D is a midpoint cuts that segment in half. So AD is congruent to DC, definition midpoint. So you can see how statement 1 gives us statement 2 and statement 2 gives us statement 3. And this last one on this page, BD is the altitude of triangle ABC. And altitude is a line drawn from the vertex that is perpendicular to the other side. So first I'm going to say that BD is perpendicular to AC. So an altitude is a line from the vertex perpendicular to the other side. So an altitude creates perpendicular lines. So I'm going to say which lines are perpendicular. BD is perpendicular to AC. Definition altitude. Now perpendicular lines make right angles. Angle 1 and angle 2 are right angles. Definition perpendicular lines. And then right angles are congruent. So you can see how this flows from step 1 to step 2 to step 3 and to step 4. So because they're both right angles, they're congruent because all right angles are congruent. Okay, so those are the important things. I do have a few more things on this next page just to go over quickly with you. And actually, I'm just going to do that in class. So we'll do this in class together. All right, so we'll hold off on that.